Advik, Astha, Iha, Vihan. Shall we start?
Yes.
जोशुआ एंड संप्रीति भी ज्वाइन करते हैं normally. All right. So I think अपना last discussion इस पे हो रहा था. Let's check. 1 mole of non-linear triatomic ideal gas was adiabatically expanded from 16 to 1. The first case is reversible, and for reversible systems surrounding an universe, all three are 0. And the reasons are system is 0 because dq is 0. Surrounding is 0 because there's no heat exchange from surrounding. Deltas of surrounding is 0 in A, B, and C. तीनों में लिख सकते हो आप 0. Correct? So delta system, delta surrounding, delta's universe. Delta system, delta surrounding, delta's universe. Same for third case. All three places you can say delta surrounding is 0. ये बात समझ में आ रही? Can I? Is it clear? हाँ ना कुछ बोलेंगे? Clear है सभी को? Raise your hand if it is clear.
Yes, ma'am. So
All
could you do the irreversible part?
I'm coming to that. Coming to that only. So delta is system surrounding universe. All three are 0 for A. इसमें कोई doubt? A clear हो गया? Adiabatic, A, all three will be 0. Yeah, is it clear? Advik, is it clear? Okay. B or C में delta surrounding is 0. Now the problem is how do you solve delta as system and delta as universe? So the first thing you have to do is in irreversible case, you have to refer to this equation. Can you recall this? Delta U is minus P external V2 minus V1. All of you can recall this expression. Basically, this is 16, 300 to 1. Let me take you to that question only. और यहीं पे क्या होगा आपको? Read the question. It's the same question. Can you recall this question? This question we have solved for reversible and irreversible. If you solve the same question, first you find this question in your notes. Did you get that? And compare this with entropy questions. So wordings are exactly same. Only difference is now we are solving for irreversible entropy. That time we solve for work done. कितने लोगों को ध्यान आ गया क्वेश्चन किया हुआ आपने? Raise your hand if it is clear. Advik? नहीं किया?
करा है सही वाला, जहाँ तक तो याद है करा है सही बार।
किया है भाई ये वाला क्वेश्चन.
हम्म,
सॉल्व करते हैं T2 निकल के आता है 229.56. रिकॉल एंड देन W निकालते हो 210 आर. नहीं किया तो फिर से कर लो. एक बार फटाफट सॉल्व कर लीजिए. राइट नाउ डेल्टा U is Q plus W. Q is 0. So delta U is W. Delta U is NCV T2 minus T1. W is minus P external, V2 minus V1. V2 is NR T2 upon P2. V1 is NR T1 upon P1. P external is P2. This equation is clear? Yeah, Asta. So can you please solve this equation? You have been given values P1 16, P2 1, T1 300, T2 not known. All numbers are known to you. Gamma is 4/3. फटाफट रखो और सॉल्व करो. जल्दी से एक बार फिर से प्रैक्टिस कर लो. Quickly solve this question. Try to get T2. Take your time. Once you get T2, आप रुक जाओ फिर वहीं पे, then we'll discuss from there. Everybody try to get T2.
So can you just scroll up 1 minute? Just a minute, boss.
How much is T2? हम T2 निकाल सकते हैं. ये इक्वेशन आई सबकी. 3 times T2 minus 300 is minus 1 T2 upon 1 minus 10/16. यहाँ से T2 निकालो. Advik, clear है? Solve for T2. 3T2 minus 900 is minus T2 plus 300/16. So आपका जो वैल्यू होगा वो 4T2 is 900 plus 300/16 हो जाएगा. T2 आएगा इतना. चेक कर लो. 229.5. और मैं 230 भी बोल सकता हूँ. 230 केल्विन बोल दूँ. Approximate 230 Kelvin. Right? So in this question, how did you solve work done? NCV T2 minus T1, which was NR upon 1/3 into 230 minus 300, that is minus 70 into 3R. That was the work done. Now, just keep this in mind, T2 is 230. How many got T2s around 230? Raise your hand if you got that. आ रहा है सबका? Advik? Now come back to the question. In our question, in this particular question, final temperature we got as 230. Correct? Now, look at this situation. You start with 16 atmosphere, 300 Kelvin, reversible. You reach to 1 atmosphere, 150 Kelvin. Same question आपने reversible में solve किया था using P power 1 minus gamma, T power gamma is constant. That time your answer was 150. वो भी दिखा देता हूँ. Same question with reversible, our answer was 150. Look at this question. ये reversible case. How did you solve in this time? You got answer 150. कितने लोगों को ध्यान है? Can you recall this? Reversible, you can use formula P power gamma is constant. Yeah, is it clear? Irreversible, you have done a minute back. Advik, is it clear? Reversible, आपने formula use किया था. Temperature 150 निकाला था, right? And irreversible, you have used this formula and got 230. So what I'm trying to do is I'm just showing that numbers are changed. We started off with something that was 16,300. We reached to 115 reversible. We started with 16,300 irreversible. We reached 1,230. Can I say points are not matching? Can I say that delta system, I can't say zero directly as it was in reversible because this case you're not reaching to the same point. If you reach to the same point, method can be anything. Your answer will be same. Is it clear or not? That is a property of state functions. Asa, is it clear? Yeah, is it clear? So state function delta S will show the property provided you're reaching to the same point. But you're not reaching the same point. You're going to 230 from 300, not 150. So what we have to do is we have to use the general result of entropy. What is that? TS is this. Right? Vihan, you've done the same thing, right? That day you were discussing.
Yes, sir, I was doing this, but like I was not getting any answer.
Yeah, you're getting this kind of thing. NCVL and D2 by D1 plus NRL V2 by V1. Just check. ये तो लिखोगे ना equation?
Yeah, yes, sir, yeah. That
Now
I
in the equation, CV is 3R. What is T2? 230. What is T1? 300. What is V2 by V1? So use P1 V1 upon T1 is P2 V2 upon T2. So what is V2 by V1? Just arrange everything. It will become this. Alright.
Yeah, yes.
Now put that number here. So if you just put that number here, you get this as delta system. 230 by 300 into 16. I can take 16 out. I can make NR ln 16 plus NR ln 230 by 300. That will make the NR ln 230 by 300 as basically 4R. Okay. Any problem on this part? Any issues? So try to get delta system. What is delta surrounding? 0. What will be delta's universe? I'll say same as system. Because system plus surrounding is universe. Okay. So universe आप निकाल सकते हो.
Sir, I think I figured out like where exactly I was making the mistake.
Okay. Okay. Is it clear now?
Yeah, yes. So it's because like I think I was taking PV like V2 by V1 as P1 by P2. I was not putting temperature terms.
Temperature will also come. It's not isothermal.
Yeah, yes, sir. That's my mistake.
Can you do it? Everyone, is it clear? अब थर्ड केस आपको सॉल्व करना है. Anybody who has solved third case? Third case is free expansion. करिए, solve करिए. Try. Thermo, you will understand, learn only if you solve. If you see things happening in front of you, it will be difficult. You have to come up, you have to write, you have to solve, you have to get answers. Okay. That's the only way. Advik, last questions clear, Advik?
वही एक बार चेक कर रहा था. So can you show it once more? So I need
Yeah,
to
please,
know
please
part.
note down this. Yeah.
Yeah.
See, method is very simple, straightforward method. I'm using the formula. N CVL and T2 by T1 and R V2 by V1. Just putting the numbers. T2 is 230, T1 is this. V2 upon V1 is P1 T2 upon P2 T1. Okay. Just complete. Complete the third part, free expansion. करिए सारे लोग. Done? नहीं?
Sir, is the answer 4 ln 2, 4r ln 2?
Very good. Answer is 4R L into a log. For system also, surrounding also. Sorry, system also, universe also. Surrounding will be 0.
Yeah. So pressure, like only external pressure gets 0, right?
Yeah. So see, in this case, what is the question? The question is free expansion. So what will happen? Can I say work done is 0? जैसे ही वर्ड देखा फ्री एक्सपेंशन एक्सटर्नल प्रेशर 0 हो गया, सो वर्क डन 0 हो गया. Yes or no? E है नास्ता. Advik, work done is what? Minus P external V2 by V1. Advik, is it clear? So external pressure is 0 because of free expansion. Work done 0. Delta U is Q plus W. Q is 0 आपका, because आपको पता है कि भाई एडियाबैटिक केस कर रहे हो. So delta U is 0. If delta U is 0, don't you think it is delta T 0? Delta U is NCV delta T. Delta T is 0. If it is delta T 0, it will have constant temperature. So what is entropy? Entropy's formula for constant temperature cases modified to Asa. This term will go. Only second term will remain, right?
Sir, how is temperature constant?
See, we're saying it's a case which is, let's rewrite once again. Free expansion. So for free expansion, how much is work done? Delta U is Q plus W. All right. And now delta U is, and Q is also 0. This is
Sir,
because of
just
free
why
expansion.
you-
This is because of adiabatic. So delta U is 0 plus 0, which is 0. What is delta U? NCV delta T. That is 0. So can we say delta T is 0? पहले यहाँ तक समझ में आ रहा है आपको? Any problem?
Yes, sir.
Yes or no? So if this is clear, then we can say, Avik, is it clear? That means T1 and T2 are same. What is entropy's formula? Delta S system is NCV ln T2 upon T1 plus NR ln V2 upon V1 is the general formula that we know. ये तो कहीं भी apply कर सकते हैं. But in your case, delta T is 0. Hence, T1 is equal to T2. Hence, the first term is becoming 0. So your answer is NR ln V2 by V1. Now, another catch. Is V2 by V1 value same as this? Answer is no. Because that was the case when temperature were different. Now temperatures are same. कुछ समझ में आ रहा है? V2 by V1 is this time what? P1 by P2. It is not having any T2 term. Because now T is same. So we can say P1 V1 itself is P2 V2. Doable? And if P1 V1 is P2 V2, V2 by V1 is how much? P2 by P1. Or P1 by P2. Which is how much? 16 by 1. Check the question. 16 से 1 पहुंच गया. से वैल्यू यहाँ पे रख दीजिए. NR ln 16 4 NR ln 2. N is how much? N 1 था? 1 more. So your answer is 4R ln 2 since N is 1. हो गया. कितने लोगों को समझ में आया पूरा मेथड व्हाट वी आर डूइंग?
And the volume part, like, why would it not be the same?
Because last time temperatures were also different. T1, T2 were not same. in the
Huh.
last case. Now T1, T2 are same, no? Check.
Right. T1, T2. Okay.
So T1, T2 same होगा तो P1, V1 ही P2, V2 हो गया.
Okay.
So the formula is modified. What is delta S surrounding? Advik.
So that's also, I'm trying to figure that whole thing out and then I'm not quite getting it.
Which part?
From this free expansion part. The other part I got it.
Okay,
This,
इसमें क्या दिक्कत आ रही है? ये सब समझ में आ रहा है? यहाँ तक समझ में आ रहा है?
या ये तो समझ में आ गया. So उसके बाद का वो
उसमें तो कुछ भी नहीं ना. ये
मीडिया.
फॉर्मूला T1, T2 सेम करोगे तो ये आ जाएगा.
हम्म.
T1, T2
मुझे
सेम है तो P1,
मुझे
V1
ये
P2, V2 होता है. भाई अगर आप P1, V1 upon T1 is P2, V2 upon T2 लगा भी रहे हो और T1, T2 सेम है, that means P1, V1 is P2, V2.
फाइन फिर.
So V2 by V1 is 16 by 1.
हम्म.
Just put the number. 16 is what? 2 power 4. So 2 power 4 को लिख दिया 4 L into.
Adiabatic, then it's fine, then it's fine, then it's fine. Yeah, then it's fine.
Okay.
Yeah.
And delta surrounding is 0.
हम्म.
Adiabatic है.
हाँ.
Delta universe क्या होगा? Advik?
So delta universe will also be 0, no?
नहीं. System plus surrounding.
Yeah, system plus. Okay, it's going to be 4 NR ln2.
Yeah, 4 R L into. Done.
4R ln2.
So,
So
could you just like explain once again what free expansion exactly is?
free expansion is expansion against vacuum.
So it's happening in vacuum.
Expansion against zero external pressure or expansion against vacuum. So
It's
P
like
external is 0. So what is the work done?
0.
That's what we are using. And adiabatic, so Q is 0.
Huh.
Abhi Q is
So
0.
that all I understood, but like, is this expansion happening in vacuum?
No, not against vacuum, not in vacuum. What is in
So
vacuum?
what do we mean
External
by
pressure
against
is 0. External pressure is 0 means it's like, let's say, one side you have vacuum and you're just putting a gas here and just leaving it. So what will happen? The piston will move automatically towards vacuum, right?
Okay,
Against
so it's
vacuum.
just moving because it has the
Pressure gradient.
Okay.
It has a force, right? Other side, there's no force. So it will
But sir,
move
like
towards.
since even if like pressure is 0, how come it is not doing any work? Like using the formula is one thing, but logically, how come it is not doing any work?
Why anything is doing work? Why there's a work?
Okay, because there's a force on it, but here it's just naturally moving up. Okay.
Exactly. Fine. Now come to the next part. Any difficulty in this? Any issues? Clear? All right. Vihan, any doubts on this? Now let's see some questions of actual exam. Answer? What is the answer?
But is it B?
So when you teach spontaneous,
Hmm?
so when you teach spontaneity, sir.
अच्छा स्पॉन्टेनियस अभी आपने नहीं किया है, ठीक है.
Yeah, that's what I mean.
डेल्टा जी नेगेटिव बेसिकली स्पॉन्टेनिटी के लिए डिस्कस करते हैं. लास्ट पार्ट लेकिन किया था थर्मो का अद्वैक, बट एनीवे चलो उसको वेट कर लेते हैं. आंसर दिस. Try to get the final answer. Yes, what's the answer?
So could you check accidentally?
Answer is A. Good. Entropy change involved in isothermal reversible expansion of 2 mole of सीधा सीधा फॉर्मूला भाई इसमें क्यों फंस रहे हो. NR ln V2 by V1 लगाना कर लेंगे. N is 2, R आपको पता है, ln V2 by V1 100 by 10. ln 10 is basically 2.303 log 10. log 10 1 होता है. So नंबर निकाल लोगे आद्विक. डायरेक्ट फॉर्मूला. व्हाट्स द आंसर?
हो गया सर 3.38.30 कुछ आ रहा है तो लाइक कैलकुलेशन करके.
गुड गुड. एनीवन हैविंग डाउट इन दिस? इट्स अ डायरेक्ट फॉर्मूला बेस्ड क्वेश्चन, कर सकते हैं. ओके. Have you solved this question earlier? JEE Advanced 2014, right?
Some multi-correct or single correct?
Multi correct. Advik gave answer A and B. Vihan gave B and C. Correct answer is
Sir, A and C. A, B and
correct
C. A, B, C.
A, B and C. दोनों मिला दो correct answer आ जाएगा. Correct answer is A, B and C.
सी वाले का एक्सप्लेन कर सकते, आई मीन मैंने सी वाले का नहीं समझा, वो ए बी का तो पता है, सी वन
टेम्परेचर कांस्टेंट है भाई. टेम्परेचर अगर कांस्टेंट है तो फिर प्रेशर पीवी बराबर नहीं होगा.
एबीसी एबीसी
आइसोथर्मल की अभी यही तो लिखा है हम लोगों ने लास्ट हमारे डिस्कशन.
याद आया साहब, याद आया. हाँ.
This question is purely based on our discussion which was happening here.
तो एक मिनट, कैन आई कॉपी द
Answer देखो.
क्वेश्चन?
Sir, could you tell the answer? I
This is
dropped off.
this is the discussion actually. Yes or no?
या
यही question. Answer is A, B and C. समझ में आया? Adiabatic because insulated vessel है, so Q0 and delta U0 हो जाएगा, W0 है तो टेम्परेचर सेम हो जाएगा, T2 is T2. कर लेंगे
Sir, why won't it be D?
because that is adiabatic formula. Can you apply that? Reversible adiabatic. Is it reversible adiabatic or it is a free expansion case?
But
Ask them.
delta, but Q is 0, so it is adiabatic too, right?
ये फॉर्मूला कब यूज होता है? P1 V1 गामा P2 V2 गामा.
ये तो adiabatic के लिए है.
No, it is only for reversible adiabatic,
अच्छा हाँ
not
हाँ
all
फिर.
adiabatic.
Hmm.
And is it reversible process?
Oh, okay.
Free expansion is not reversible process, right? Is it clear?
No, so this is like free expansion case.
This is free expansion case, no? So read the question. They have written vessel at internal pressure P1 expands irreversibly against zero external pressure. Read this line
Yeah,
carefully.
yeah, that I got. But Q is also 0, so Q is 0 and adiabatic, right?
Q is zero adiabatic. W is zero because of external pressure against you are having right zero external pressure. So W0 Q0 so delta U कितना हो जाएगा?
It will be 0.
Delta U is zero so delta T is zero.
So T is T.
Delta T is zero so temperature is same, initial and final. Temperature is same so isothermal formula is applicable, right? Temperature is same P1 V1 is P2 V2 for a given case.
No, that I got. My question is that if Q is 0, then it is adiabatic too. Then, since it is not reversible, that is why we cannot apply this. Acha, had it been reversible, then the all four would be correct.
Correct. So just come back and again revise it carefully क्योंकि आपने एक बहुत बड़ा डाउट पूछ लिया. इससे समझ आता है कि यहाँ पे इसमें दिक्कत है. See this. When we have done this, right? And we got these three formulae.
Yes, sir. Yes, sir.
These three formulae were where? Only in which case? Reversible
Reversible.
case, right? And for irreversible, this formula is not applicable because integration is not applicable, you see? Effect of these two things. So this will never result in that P1, V1, gamma and all those things, right?
Yes.
It is only in reversible. Is it clear now?
Yes, sir.
Okay. Fine. So अभी कोई डाउट नहीं इसमें पक्का?
No, sir.
पूरा
समझ आया.
इंटीग्रेशन यहाँ से आया था, right? T पर gamma minus 1, P पर gamma and all. That is reversible case. So this question is clear. देखो एडवांस का क्वेश्चन है बट ये एक्चुअली 5 सेकंड 10 सेकंड 15 सेकंड में सॉल्व हो जाएगा आपसे अगर आप ठीक से समझते हो कॉन्सेप्ट्स को, राइट? ट्राई दिस. What's the answer?
So can you check?
Yeah. X to Z, X, Y, Y, Z. Can you write like this? A is correct. Now check work done. X to Z, X, Y, and Y, Z. Can you write like this? No. We can say work done X, Y, Z is X, Y.
So
Because Y is
the
0.
work done part, okay, can you explain it once more? Just a minute.
Yeah.
Hmm.
So work done part, can I say Y to Z work done is 0? Because it's a constant volume thing.
Yeah.
Okay. So Y to Z अगर 0 गया तो XY plus YZ is XZ, XYZ, right? ऐसे
Hmm.
आओ या फिर ऐसे ऐसे आओ, इसमें ये तो 0 ही है ना.
अच्छा, okay, you can even take it उस way में फिर.
Okay, but you can't say this. Okay. So which
Yeah.
option is making sense?
A and C.
A and C.
Fine.
ठीक है. How many of you understand that? Any doubt? And delta S is a state function. Delta state function है तो आप इधर से आओ या इधर से आओ, एक ही बात होगी. Work done is not a state function. We can't apply for work done. Here is it clear? Asta, is it clear? Any doubts you can ask. यहाँ को doubt लग रहा है.
So the C part, it's
See, what is work done for this process? It's a constant volume thing, no? Delta V 0, work done is how much? P delta V. Delta V 0 है. If
okay.
you, it's
Okay,
an
got
isochronic
it.
process. Isochronic process work done is how much? 0.
Hmm.
Isochronic work done is 0. So YZ is 0. XY to YZ, XY plus YZ is just XY
Got it.
because
Yeah.
YZ is not there, right? Done. So option C you can mark. देखो ये भी जेई का क्वेश्चन है, 2012 में आया हुआ है.
सर ऐसे क्वेश्चन अभी भी आते हैं क्या?
हाँ बिल्कुल आते हैं. ये लीजिए 2016 का क्वेश्चन है. Try.
So there's no reversible, irreversible in this.
कांस्टेंट एक्सटर्नल प्रेशर है तो रिवर्सिबल होगा क्या? कैन कांस्टेंट एक्सटर्नल प्रेशर भी रिवर्सिबल?
No.
So try.
Let me check.
You can tell, you can tell.
So third option.
Which one?
So third option.
Answer C, good. Delta surrounding is minus heat exchange from surrounding upon temperature. यही सीखा आप? ओके, हीट एक्सचेंज कितना होगा सराउंडिंग से वो निकाल सकते हैं. So 1 liter to 2 liter against a constant pressure of 3 atmosphere isothermally it is being done. So what you can do is Q system is this, delta surrounding is minus, or we can say exchange from surrounding upon T. Exchange from surrounding कितना आ रहा है? Q system is how much? Q system is delta U minus W, और delta U is Q plus W पता है आपको. Delta U already 0 हो गया. W निकालोगे 3 liter atmosphere आ जाएगी. Put that value divided by temperature and put a minus sign. कर लेंगे? Yes. Heat exchange from surrounding minus Q divided by temperature. और ये वैल्यू आपको मिलती है डेल्टा U is Q plus W से. इसमें क्या क्या जीरो मेरे पास? गिवन केस में डेल्टा U 0 है, Q is minus W. So minus Q is basically W. Put that number, get the numbers right. कर लोगे? All right. ठीक है, नेक्स्ट अब शुरू करते हैं हम लोग टुवर्ड्स some portion which is also common with thermo part, we'll see, and then we'll come back again. So right now ये आपका एक सेगमेंट कंप्लीट हो जाता है. Write down the heading enthalpy or change in enthalpy. So when you talk about enthalpy change, what is enthalpy change? Yes, what are different types of enthalpy change possible? Term delta H represent enthalpy change at constant pressure, and term delta E represent enthalpy change at constant volume, right? अब यहाँ पे बहुत सारे terms आएंगे. Enthalpy of sublimation, vaporization, hydrogenation, combustion, hydration, dissolution, atomization, neutralization, formation, fusion, solidification, etc., etc. So let me just get one file quickly. Okay, so right now, delta H is enthalpy change at constant pressure. Delta E is enthalpy change at constant volume. पता है अपने को दोनों चीजें? Okay, delta U is Q plus W और D U is DQ plus DW, ये आपको पता है. Reversible है.
One minute, एक मिनट से ऊपर थोड़ा सा करना होता है, एक मिनट.
So we'll be studying thermochemistry now.
Yeah, both are together only. Thermodynamics and chemistry are one topic, not two different topics. It's called
No.
chemical energetics, right? So, yeah.
So thermochem as in the enthalpy, right? Del HF not and all.
Everything, yes. And then again, there are some portion of thermodynamics we'll cover after that. Okay.
Good answer.
So first we'll complete enthalpy and then we'll go back to complete Gibbs free energy and some other discussions. Fine. Now, H is U plus PV. H equals U plus PV you can apply for liquids, for gas, ideal, real, सबके लिए apply कर सकते हो. ठीक है? Now let's say you have a reaction A gives B plus energy or heat is coming out. If heat is coming out, it's called exothermic reaction. And if a reaction is A plus heat gives B, that is endothermic reaction, means we are supplying heat, right? ये तो पढ़ा आपने. If you supply heat, it is endo. If it is coming out, it is exo. Any doubt in this? If energy is coming out, whose energy is high? Product or reactant? If in the reaction heat is coming out, whose energy is high? Reactants or product? Apply conservation of energy.
Oh, reactant.
Reactants will be high. If reactant is high, product is low. Then only along with product energy will come out. If it is vice versa, product is more, reactant is less, then you have to supply energy. This is energy conservation. Simple. So can we say this product minus reactant's energy is known as delta H? I think this diagram we have done with everyone. Yes or no? Anyone who has not done this? आपने नहीं किया है? Okay. Draw करिए. Energy versus progress of reaction. Energy on y-axis, progress of reaction on x-axis. Energy on y-axis, progress of reaction on x-axis. Now this is your baseline, and this is how energy is improving. This is the y-axis, right? Energy axis. This line is indicating energy of reactant, and this line is energy of product. ER and E. Are we clear?
Huh.
So in this question, EP is more than ER. Please check. EP is bigger, ER is shorter. तो कौन सा रिएक्शन हुआ ये एंडो हो या एक्सो हो?
So इसमें product is the same. So then it's endo.
वेरी गुड. EP माइनस ER, ये जो गैप है, EP माइनस ER का जो गैप है, ये गैप, दिस इज कॉल्ड डेल्टा H. ओके,
The distance between EP and ER, the magnitude.
yes. EP minus ER is delta H. So note कर लीजिए. EP minus ER is delta H. Now as you can see, this ER, to reach this line which is called energy barrier, which is necessary to get product. So reactant will go with a transition state, convert into product. Transition state, convert into product, right? So it's going to touch the top and then go to product. In this process, how much extra energy is needed here? बताइए. Activation energy. This is called activation energy. Activation energy is defined as energy required over and above ER to convert R into P. ठीक है, इतना है मेरे पास एनर्जी, बट इतनी और चाहिए ताकि ये प्रोडक्ट पे कन्वर्ट हो पाए. It is as good as taking a physics example. A ball is given. You have to send this ball here. So if the gap is h, you can say mgh is half mv square. The problem is, if you apply the formula, you'll end up on the left-hand side, not on the right-hand side of the cliff. If you go and cross the cliff, what is the minimum required height? It is this. समझ में आ रहा आद्विक? अगर आपको बॉल को उधर भेजना है तो क्लिफ की इस हाइट को क्रॉस करना ही पड़ेगा. मैथमेटिकली तो यहाँ पे आंसर मैच कर जाएगा ना, बिकॉज दिस हाइट एंड दिस हाइट आर एक्चुअली सेम. Mathematically, yes, answer will match, but actually answer will not match because you are on the wrong side of the cliff. Is it clear? So what is the minimum h which you have to cross? It is this. So what is the minimum velocity? That is root 2g capital H. If I call this whole thing capital H, that is that particular h, not this h. Okay, which looks like. So delta H is also like that. Delta H is enthalpy change. On the face of it, it looks like this is enthalpy change. This much energy is sufficient for reactant to become product, but no. You will give more energy, some energy will come out, and the difference of energy is delta H. Okay. But just with delta H, we can't do the reaction. I repeat, just with delta H, we can't do the reaction. So what is the minimum energy required to do the reaction over and above reactant's energy? It is called activation energy of forward direction. Draw this diagram. For the backward reaction, this is EAB. Can we say EA forward, this value plus ER is equal to EA backward plus EP? Check कर लो. Same ही होगा ना? This plus this is same as this plus this. Check. Note down. So can we say EP minus ER is delta H, EF minus EAB is also delta H. ER plus EF is EP plus EAB is E threshold. E threshold basically this complete height. Advik, is it clear?
Yes, sir.
Iha, is it clear? Astha, is it clear? Vihan? Astha, any doubts? All right. So उस पे बेसिक क्वेश्चंस आपको आने चाहिए. न्यूमेरिकल क्वेश्चंस भी आते हैं यहाँ पे कई सारे.
So what is EAB? That is okay.
EA
Backward.
forward, EA backward.
Fine.
Okay. रिएक्टेंट से प्रोडक्ट जा रहा है तो फॉरवर्ड देखोगे, अदरवाइज बैकवर्ड. ठीक है. आंसर दिस क्वेश्चन and draw the diagram also. Draw the diagram and show all the values. Do it now, quickly. EP110. Okay. Done, everyone? EP minus ER is EA forward minus EA backward is delta H. यही यूज करना है. सिंपल मैथ्स है. लगा लोगे. सो सॉल्व करोगे. EP कितना आएगा? 110. E
80.
threshold is 150. Okay. EA backward 40. कर लेंगे. चेक करें. स्ट्रेट फॉरवर्ड फॉर्मूला यूज करना है आपको. It's not difficult at all. All right. Any problem to this? Any issues? So from here, we'll see in the next class. Okay. With catalyst, what happens? Let's mark this. Okay. Please revise. Okay. So next class will be on Monday, Tuesday, Wednesday, Friday. Next is Friday. This segment. Okay. All right. Bye-bye.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Bye-bye.